So again, welcome everyone. Today we are talking about summary across trials, our add-in tool for summarizing multiple studies, and we're really covering the basics. This is part one of two, but we will try to cover the simplest example pretty much of kind of each phase of using ST today, and then next session we'll just build and do some more sophisticated examples and see a couple more things next time around. But our goal here is to be somewhat self-contained in this 1 hour to get you going. And then if you're able to join us on the next session, then we just take everything a little bit further. So just real quick introduction for ST. Again, it's an add-on, so you can purchase this on top of your ARM license, and then the functionality is just unlocked with the license. There's not like a separate installation. It goes just on the same computer where your ARM is at, and it's useful for analyzing multiple trials. ARM, of course, is focused on just you open one trial, let's do the analysis on that data. Here in ST, we are looking to combine trials. Maybe you've performed an experiment on 10 different sites and you want to bring that all together to make some conclusions. Maybe you've done similar research over the last 3-4 years. You want to combine those. Those are all common examples for what ST really is great at. And so the file type, what we work on in ST is called a criteria file. So that's what we'll end up creating in ST here in a moment. And really all that criteria is, it's a question or a query if you want to be technical about it. We're really formulating a query on that set of trials. And so to just kind of simplify and map out the phases we'll see in ST today, it really boils down to just three components to this question that we're going to build up. We're going to choose the number of trials that we want to search. Then looking at those trials, let's create a list of treatments, our products that we are wanting to summarize. It doesn't have to be every treatment that exists in all of those trials. We can curate a list of the ones we actually care about. And then the last step is the data. How do we want to combine the all of the data columns together to get a analysis that answers the questions that we're looking to answer with that question. So that's kind of our roadmap today. I'm going to toggle over to ARM and just to show the starting point here. If you have the ST add-on, it's just a simple toggle. So under the file menu here, I just have a toggle to switch over to summary across trials. We get our little loading screen, but you'll see it looks a whole lot like ARM. So if you've used ARM for a while, this will seem mostly familiar, hopefully, at least. So as we get started here, the first step is to create that criteria file. So the process is a lot like when you start with a new protocol in ARM. We're doing something kind of similar. We're going to start with a new criteria. Let's create this question. And so we have the first step within there is just like in a protocol, we have to choose the structure, the template for which the files will be built on. The standard GDM def is almost always chosen here, unless you're working with a company that has their own specific customization, which slowly but surely are becoming more and more rare anyways. And so really we're selecting here the same, whatever selection is made in your trials, which in almost all cases would be this G all definition. That's the one that gets chosen by default. But if you were, if you're used to working in the seed definition, then certainly if all of your trials are in that one, that'd be about the one case you might pick something different here. But vast majority of studies are in that G all. It's the multidiscipline definition we have for pretty much anything. So now we are ready for step one in creating our question, our criteria. Here are the selection for the trials to search. So there's two options as to the source. If your company uses the ARM trial database, you can query, you can pull trials right from that database itself. So that would be the option here. Probably in most cases, you would select the trials that's just available on your computer. They could be just on your local hard drive, or if you work with other people, maybe it's on your company's OneDrive, SharePoint, Dropbox, network drive, wherever they are. As long as your computer can see the files, ST will work just fine to pull in and read that information. So you select the option, and then the option itself is a button to actually bring up and make a selection. So if I click here, it will bring up my study list, so that way I can search and find the files that I need. We've talked about the study list here in a recent webinar. Just real brief, this is the list of trials and protocols that you've worked on in ARM. There's a rebuild option, so you can train this list to find everything that everyone has worked on in your company, to make sure it's a complete list, especially in this idea here of wanting to query, find our studies that everyone has worked on, in order to pull that information in. That's pretty useful. So that's the main list here, is all of the studies, and the top portion are filters. So you'd be able to narrow down your search here to find the particular studies that you are interested in. So a lot of filtering capabilities here on all sorts of information that that you can find here, because commonly you have a target in mind as to what you need to summarize. Not necessarily do you know the list of trial IDs automatically. That might not be helpful. I can't just scroll through this list and pick and pop which ones I want. It might be much better to filter based on what you're looking for. So it might be a case where my target is on a particular crop. We have a section here, so I could filter down my list, either the common name or the code, if you're more familiar with the codes. I definitely am not, so I'm going to cheat and use the common name. If I'm looking for what we've done on wheat, I can make sure to choose any of those. Once I make a selection and press OK, the list shortens to only trials that have that selection. So at the top, I can see now I'm only see 33 out of 92. And then I can continue to narrow this down. Okay, yeah, studies with wheat, but maybe there's a specific pest that we care about as well. So I can go down and get just the Septoria leaf blotch, and you can see the list just gets smaller and smaller. Then once I have found the ones I want, I just can select the list of them. For today's example, I'm going to use our tutorial study list. So there's just a toggle at the bottom that just switches over to the list of trials that we include with every ARM installation. They're just examples that you can mess around with, kind of see and learn a little bit. It's also helpful for me because then I can do these steps, and if you were wanting to follow along or watch the recording later and do it kind of side by side, that makes it really easy because you have this exact same list as well. So we have a couple sets actually of ST examples, and I'm just going to take these simple ones here. The study ID is ST example 1 through 6. And that's going to be my selection here. Real quick, there was a question on the study list using the rebuild. Yeah, it normally should be pretty fast. ARM just opens up each trial just in memory to be able to kind of know what's in the trial and fill in this table. So it really shouldn't be taking hours, unless you have 2,000 trials or something, something like that. That would be one reason. If there just is an extremely large number of trials, it could take some time. But if it seems somewhat suddenly to be a lot slower than it used to be, I would maybe start with, where are the files? If they're all on our company network, is my internet connection weaker? Because you can imagine if it's even just a little bit slower to open up a trial, multiply that by 100, 500, suddenly you'll notice a big difference, even if incrementally it's just a little bit slower, that'll really multiply out. So that would be my first guess, is if just that connection to wherever the files are is kind of slow. That could cause it. Otherwise, if you're still having troubles, reach out to us in our support box, and we could connect to your computer and try to troubleshoot some more. Because yeah, hypothetically, it shouldn't take tons of time. 10, 15 minutes maybe if you've got a couple hundred, go grab a coffee or something. But hours, it does seem quite unusual. Yeah, so thanks. There's an example about 2,000 files, and yeah, would take an hour or two. So yeah, just depending on how large of a set, it can take a while, just because that's a lot to read in memory. But yeah, without that many files, that would tell me something is just delaying the process, and then multiply that by a couple hundred studies. Suddenly you get a lot of wasted time. So that sounds good. We can look at that. All right, so today here I have selected those 6 example trials that we'll use. And so when I click OK, just a small change back on this dialog, but we'll see this again and again. There is a number 6 that gets put in parentheses. And that's just our nice visual reminder we have made a selection. So there are 6 trials that we've chosen. And that tells me we can continue on. Real quick, there is an option here if instead of the study list, if you just want to select files from a folder, you can do that. So if I turn that on and then press this button, then I get this select batch dialog. It's kind of the old school Windows dialog. So it's a little clunky if you have your files spread across a bunch of folders. Kind of one of the reasons we've got the study list. It makes it easy to search across all those different folders, however you organize things. But if for whatever reason, just going through the folder structure is more of your speed, that's an option here. All right, next, just one more kind of settings dialog here, just getting us off the ground. Not a whole lot applies to us just yet. You know, we don't have an untreated treatment or anything yet, but probably the one thing to consider would be your treatment units. Just which system do you use? That would be one thing to set here before we get into the treatments here in the next step. I think my examples are in metric. We'll find out for sure when we get there, but ARM's really good at switching between the, you know, converting between the two anyway. So, and then pressing next. Okay, so that wraps up our step one. That gives us our, you know, trials to search. We've got those 6 of them selected. You'll see on the screen here at the bottom, there's a panel that'll just remind us of some of that information about those trials that we've selected. So our second step, ARM kind of brings us, or excuse me, ST brings us right to this next step, which is the treatments list. So we've got a treatments editor, very similar to what it looks like in ARM, but we have a question here. ST is offering to build up the list of treatments. How should we at least start? We can get started instead of working just from a blank list. We can get this filled in to start with, and we can always tweak it once we have a starting point. So there's real basic options of I can choose a protocol or a trial, and ST will just copy that treatment list exactly the way it is in that specific file right here in our criteria. And you know, if I have a small set of trials or a very, very standard set of trials where I've dispersed them all from one protocol, this might work just fine. If I know the list is the same in every file I'm summarizing, that's real quick and easy to do so there. But in most cases, it's not that simple. Whether it is just a bunch of different protocols or several different years and different sources and things like that, maybe we're not quite so lucky to have everything fit nice and neat in that way. So we have this function called build treatments. And what ST will do, it will look in all 6 of the trials and scan the treatment list of each of those trials and come up with an overall list of all of the unique treatments that we have in those trials. So if I press next, before we can do that, we need to tell ST how to determine what treatments are different and what are effectively the same. So we choose the specific treatment fields or the columns from your treatment editor that ST should look at to decide if something is different or the same. So obviously something like treatment name in most cases would be an indication it's a different product entirely. We could choose formulation if that was something that we were studying, that maybe it's the same product name, but we were testing different formulations of it, perhaps. Probably the most common one, and it is selected by default, would also be the product rate. Maybe more common that if I do have the same product, so if it has the same treatment name, but a different rate, do I want those treated separately? And so that is selected by default in that fashion. Certainly, if I didn't want that, if I did want to combine the data because it didn't really matter, that is a possibility. But in my case, I think our example studies are herbicide, and so I think I do have a product, same product name at 2 different rates, and I want to keep those separate in my analysis. So I will choose the rate and rate unit as well. But the rest of these that are empty, ST will just ignore when comparing. So if we go next, we get one more chance. If for whatever reason I didn't want to build from all of the studies, I could change that selection. But in this case, yeah, I do want, it really is helpful to really get to see what we're dealing with in all of our studies. This goes really fast since we have a really simple example, but that first screen we saw for just a moment, ST was just opening up each trial. And then it would just say, hey, we found a treatment, we found another treatment, and then it would open the second trial, scans that list. Is there any more treatments to find? Then it would open up the third, etc. Then when we're all done, we get a simple summary. It looks like we found 4 treatments. They all came from the same trial, which tells me that I've got a very standard list. So even though we opened the second and the third, there were no treatments that appeared to be different than these first 4 that we found in the first trial. So like I said, really basic example. We're kind of living a dream in this first example we're doing today, where everything just works real well for us. Certainly next week in our part 2, we'll go through an example where it's not nearly as clean. There are lots of tools in ST to overcome things like that that we'll spend more time on later on. But here we're kind of just lucky. We'll just look over this real quick. I've got that list. It looks much like an ARM treatment list. The small difference is that we have the fields to match. You can notice that treatment name is just a little bit darker shade. Same thing for the rate and rate unit. Those are what we used to decide if something is different or not. And yeah, I was incorrect. I could see even if we just used treatment name would have been good enough because we got a super stamp, stamper, sure kill. It actually was somewhat irrelevant whether we chose rate or not because everything has a different treatment name. So it would have found those differences anyway. So that's the build treatments. Like I said, really useful for really just gauging what do I have in these studies. It's certainly possible we have a 5th, a 6th, a 7th treatment. You know, maybe somebody had, typed something in wrong. So if in one of the trials there was a typo and they didn't put it in exactly the same, you could see something kind of like this come in as treatment 5. It's intended to be the same as treatment 1, but it just didn't quite make it to be the same. And as a researcher, I know what this is. These 2 are the same. It's super obvious. But for the computer, it's not. It's not that obvious. They are different, and so the computer is not going to automatically combine those. It's going to think they are different. So that's the type of thing that we have to tackle. And there are some tools to kind of resolve that in ST. So we wouldn't have to go back into ARM, into those individual trials, and spend a lot of time standardizing the treatment descriptions. In general, that might be a good thing to have, that you want to do anyway. But certainly there are some tricks and things that we'll see next time around to be able to fix some of those types of things, even just in the summary. Because certainly if we're trying to look across 100 trials, thinking that we have to go back and open up 50 of them to get the treatment list to be perfect doesn't sound very efficient. So certainly we'll go through some of those next time around. But I guess real quick, actually, we'll just hint at the one since it's pretty straightforward. All the way to the right of the treatments editor, there are 3 special columns that are only in ST. And so kind of the biggest bang for your buck on that problem of, oh, this is a mess, but they really should be the same. So like our 1 and 5 here, they are the same, but they just don't look that way. This equivalent treatment column is the best way to, or I should say the simplest way to get those to combine properly. So if I put the number 1 in the equivalent treatment for this typoed super SOMP, then when ST goes to run the summary, any data that it finds related to super SOMP is going to automatically be pooled in with treatment 1. So there isn't going to be 5 treatments in my summary, there's only going to be 4. Anything with this 5th one is just going to be treated as if it was treatment 1. So that's a quick way to fix some of those issues. You just go down that list and just match up whatever goofy thing that isn't quite right, just put the number of what it should be in that equivalent treatment. And then we'll see that the information gets combined and treated nicely. All right. So yeah, we know in this case, this line isn't going to do anything since we just made it up. I'll keep it here just for fun. We'll see what happens. But that's the real short treatment list here. So the third and final part of our question, and this is usually the toughest part as far as knowing what to do when you're just starting with ST, because ARM ST stepped us through the first 2, just kind of held our hand, but now we're kind of sitting here going, what's next? So I like to just hammer on that there's 3 parts to our question. So far, we've just done 2. We've just done the trials and the treatments. So that last part of the question is what to do with the data. So that we would move down to the assessment data editor. Looks like we're just getting a question about our numbering of treatments. I'm just going to say, sure, I'm not worried about the numbering of the treatments anyway. So I'm not sure why it's bugging us about that. Okay, perfect. So moving to the assessment data editor, this is the way we can fill in that last portion of the question. What do we do with our data? I'm going to go back to our PowerPoint for a second. Just to talk through this final portion of our question, the assessment. Trying to visualize what we do with the criteria. So I'd like to make the comparison. If you imagine all of our trials, I've got 6 trials that we've selected. Each of them have a variety of assessments we've performed. Maybe if they're all structured, they are about the same list of assessments in each one of them, maybe not. But we have all these different assessments, and we've got the header details about specifically what was done in each of those assessments. We can imagine each of those columns is like a card in a deck of playing cards. And what we do in the assessment criteria is like setting out a list of instructions on how to arrange this deck of cards. So in the deck of cards example, I could pick it up and I could be told I want all of the even number cards to be placed on the desk. If there's an odd number card, I don't want it. You know, throw it on the floor, set it aside, whatever. All I'm interested in is even numbers. And so that would be kind of the most basic thing we can do is just drop out things we don't care about. Or alternatively, select a specific thing I care about and ignore everything else. So we'll see that as kind of the first example, how to say, I only want even numbers. Then we could also take of those even numbers, I want to arrange or group them differently. So instead of just one pile of cards on the desk, I want them in 4 different piles. Let's sort them out by suit. So I want a stack of all of the even spades, then the stack of even hearts, the even diamonds, 4 different piles then on the desk. So that is the second type of action that we can do with our assessments. Group them differently instead of having everything that we find all in one big group. We can split them up by some aspect of them. And we'll see that we use a wildcard for that. So those are really the 2 big ways we interact with the assessments. And the goal here then, going back to ST, is the assessment editor. This is how we can list out those instructions. And then once we're done with these instructions, we'll be able to run the summary and actually see our results. So this first assessment column, it's really a criteria column, our first set of instructions that will give ST. We'll start with that very simple example. So in the rating type, that's kind of the number 1 field, that is what is it I did. If I click into that field, I see a little gold box. Just like we saw on the study list, that's our filter. So by clicking that gold box, I get to see a list of all of the unique rating types in all of the data columns, all 6 of them here, all of the data columns in the 6 trials that we have selected. So I can select to narrow down only particular columns that I'm interested in. So maybe the thing we care about most here is our yield. So I am going to select yield and click OK to basically say, I only want columns with the rating type of yield. Any other column that has yield, I don't need them. Put them on the floor, doesn't matter. Now, of those columns with yield, maybe I need to be a little more specific. I could go down to the rating unit, and I might want to be a little more specific as well, knowing that, especially with yield, depending on how I fill in my columns, if I had yield described with my raw weight, and then I did a conversion to standardize it per hectare or acre, then I might be pulling in 2 different data types together into one. So I do have to be a little careful and think about how I'm making these selections. I might also need to go into the rating unit to be careful about what it is I'm grabbing. So certainly, sometimes at this point, especially if there's some confusion when I run the summary and it doesn't feel like I'm getting what I want, a lot of times I'll open up another ARM, I'll actually open up another ARM window and stay in ARM and open up one of those trials. And we can kind of see, okay, how is it I'm describing the assessment I want, and make sure to consider, am I making my question so that ST will find how it is I've put ARM, how I've put the data into ARM. So that can be really useful, most especially in troubleshooting. Probably not the worst to just kind of craft the query at first, see what we get, but then you do have to really kind of want to think about what is it I'm looking at. So just to go through that real quick, let me just open up one of these trials in a separate window. It's nice, I can just have two of them here. Sometimes I could go side by side even if I'm really struggling to make it work. So I've got a bunch of control, just kind of looking at our rating types and units, a bunch of control assessments. And then at the end, sure enough, I am putting in yield. It would look like my raw amounts in kilograms is what I put in first, and then a moisture column, and then my actual yield conversion. Wasn't sure what the quintal, okay. So that would mean if I just simply left my query as yield, then in each trial, I'm going to be grabbing both this data and this data and pooling them all together. That's going to be a mess. I don't think that's going to tell us very much anything. So that is kind of one thing to watch as we're making this criteria. It's very easy to get ST to give you an answer. It'll take your question and it'll run it and give you a number. And you do just have to then, as the user, make sure you're looking at what it gives you. Does this even make sense? Because it can definitely give us a number, but that care needs to be making sure that it's a number that even makes sense. That's not pulling in too much or too little, things like that. So there was an example here, or a question. This list, it is possible to choose more than one to combine. Let me use a different example than the yield, because this obviously would be a terrible thing to do. But if, let's say that control we were more interested in. So I choose control as the type of assessment. Then we were looking, then, looking at this rating unit list, there was a percent and a percent of check. And so that might tell me, well, maybe somebody, when they were doing their control rating, only chose percent while someone else had the percent of check. And I'm pretty sure both of those are the same. They really both are valid for this assessment. They're both the same type. I mean, to me, they're both percentages. I believe that they are perfectly fine to combine. You can choose more than one. And then when you click OK, you can see that it does put both units in this box. And so it will combine those together. Yep, and the example there too you had for the rating type as well. Any of these fields, you can select more than one if the description is just a little different, but the data is the same. And that's just one thing you want to make sure. I know the data is the same. It was just described differently. Then you certainly can do more than one selection, and it'll combine those together. So great question. So I'm going to toggle back just to our example of the yield. And in this case, I do want to choose one or the other. I think we'll take the converted yield. That will be more useful to us. And now the rest of these, so some of these we've had these wildcards filled in. For all of these, I really don't need them. So if I wanted to, I could even just cut those pieces of information out. So to demonstrate what that wildcard means, so this asterisk technically is no different than a blank. What the asterisk wildcard, that little symbol we call a wildcard, that just means select all. So it's really the same as a blank. We're saying SE description or part rated. It doesn't matter to me what the entry is in that field. It can be different, it can be the same. It's irrelevant to me. I've already picked what I care about. So the asterisk, functionality-wise, is the same as a blank. Both of them just say, we don't care about this field. This at symbol, the A with the circle around it, that is our match and separate. So that was that other example on our slide where we said, hey, I've selected all of the data. In my case, I've selected our yield columns. I want to summarize those, but within that stack of all of those data columns, I want to break them out into different groups based on some piece of information. And so that is this @ sign to match and separate. Let's separate out maybe by crop. In yield, that would make sense if these trials, some of them were on wheat and some of them were on maize, whatever it is. Those are about the only two options here in South Dakota anyway. So, but maybe not. The better example probably would be if we were looking at the control, looking at particular pests. That would be a very common example where you'd want to separate by different pest. So if I'm wanting to get an idea of our control on our products, certainly wouldn't make any sense to combine all of those assessments together if there were different pests. I want to separate out to see how well did our products do in controlling this one pest. And then in a separate analysis, let's see how we did in controlling this other pest. And so it'll split them out. And we'll spend more time on some examples of that in the next session. Certainly, if they end up all being the same, the @ sign doesn't really hurt us for them to be there. So I'm going to end up just leaving the rest as is, and we can just see what we get for a result. Okay, so that kind of wraps up this last portion, the last step in our question. So we really have our question filled out. Before we do the analysis, just real quick, want to save this criteria. So just like we save a protocol or a trial, we should save this criteria. And so again, what we're saving here is not the data. We're just saving the question. All we're really doing is saving the three things we've done so far: that selection of trials, the list of treatments, and our instructions for what to do with the data. But there is no analysis being saved here. There's no data being saved. It's just the question. And so this is a separate file type, STC, not that it matters very much, ST criteria file. And I'd just like to encourage naming the file to match the question we're asking. That'll be useful for if you want to return to this analysis or do a similar analysis in the future. If I'm doing it this year and then next year we do some more studies in this same vein, I could always open up this criteria next year and then just select and add more treatments to my list and then run that analysis again. So there is some carry-on value here. But the key is just, make use of the fact that you can have a fairly long file name, and just describe, maybe it's the experiment, so in this case it was, ST exam was like our name of the experiment because we had all 6 of those. Maybe the product that we care about, that, super stomp was the thing we're really investigating, and that, this was yield. You can formulate almost a sentence even here of just what was it that I was doing, or put some symbols in between there to kind of know, just tell yourself or anyone else that might want to return to this, what was the question I was trying to answer. And there is a longer description here that if you're strategic in the name of the file, you almost don't even need that description. But this just allows us to have this file so we can return back to this spot again in the future. Okay, so now to actually run this query, run this question, under the Tools menu, we can select Begin Summary. Quick overview of what we've accomplished so far here. We can see we've got criteria in the treatments. That was our list of treatments, our 1 column instructions, and our 6 trials that we're going to select. When I click OK, ST reads all of those trials, then performs that query, that question. And we get a nice summary. Sometimes it's messier than this. There may be warnings about assumptions of ANOVA or various other things depending on what all stats were going on in the background. But I like to scroll down to the bottom to see this summary at the end, because I can see that we tried out 6 trials. 6 of them matched. So every single one had at least some data point that got into my summary. And we ended up with 6 different assessment columns, kind of a coincidence more than anything that happens to be the same number as the trials, because we are combining data. There's no reason that should necessarily be the same number. So what we have then is really a nice preview. It's not all of our analysis, but it's a good portion. This is kind of the heart of the criteria that we have. And what we see, there's kind of 2 different types of columns on this report. There's one shaded in blue, and it has just a simple number at the top, and that is a grand mean column. So this would be the combined means across all of the different assessment columns that we found to match in our particular criteria that's described right here. So these are then grand means, and we get statistical separation run on there. And it's nice because then we also have a count, so we can see actually how many data points went into these means. And at the moment, it's not very grand because we've only got 1. So we didn't combine a whole lot, but we'll get into that, especially in the next session. And so then the column in white has the trial ID at the top. And so this is an individual trial that was included in this overall grand mean. And right now I'm so segmented, they all have just 1-to-1 ratio, which is not really what we want. And actually I can see in just comparing, we said they all should have yield and the quintile selection. The only difference is this timing. So what I'm going to do, and super common to do in ST, is you see your summary, you go, it's not quite what I wanted. I'll close this and go back to my criteria and tweak my question. There's just a lot of back and forth of, oh, well, I need to formulate my question better. So what I'm going to do is just clear out all of these wildcards. So now I have just the most simplest yield in our unit that we want. And then I can begin summary. Use the toolbar, which is the same as this begin summary. Same idea, except now this one small difference, there's just one match column. So we've tweaked our question just a little bit. And now what we have is just the one grand mean column. We have these nice means that actually come from 6 different trials. And we can see all 6 of them here to the right. So we can see the individual, the performance in each individual trial. And then this mean here will be the grand mean across all of the different trials that were combined there. And we have a lot of options. If I open up here, you can turn on and off all sorts of things. If you don't want to see the individual trials, or you want to add, there's all sorts of different pieces of information that you can add or remove from what we see on this report. But this is kind of the bare minimum here. We've got just a really ugly amount of digits because these are the calculated, mostly because of the yield. The converted yield back in the trials themselves have a lot of digits. So for my sanity, I'm just going to put in number of decimals as 2. This is one case here where this is actually just instructions to ST, and it's not actually the criteria itself. But pretty much all of these other fields are. So if I run this analysis one more time, it's just 1,000 times easier to read. There. Now we can actually kind of understand what we're looking at here. So that's the overall process. Just calling out some things we'll do in the next session. There is some graphing capability. Here, once we have the summary the way we want, there's some graphs we can generate. We'll spend some more time in the options as well, just to show some specifics on what can be put in, what can be taken out, things like that. And we'll definitely dive in a little more into that really messy step that we first saw, where everything was split out way too much. How do we actually craft this into something that we want to see? We kept it real simple, where there really is just one yield column. Certainly, it gets more interesting if we use those control assessments. Since we had several of them in each trial, how do we get that? How do we manipulate our question to do specifically what we want? So that'll be some things we can cover next time around. Just to wrap up, just to see this all the way to the end, since I've got just a minute or two, once we're content with kind of what we're seeing here, that, hey, this is the analysis I want, I'm going to press the next button, and we do have a report of kind of what we just saw. And so this print dialog, just like you've seen in ARM, we can send to different file types. I'm going to preview it on the screen here first, so I can kind of show what it is we have in this report. Looks a lot like an ARM report. That main table we just saw on the screen is here in the report. We do get some more statistics involved as well. And this, of course, goes over to a second page. We do also have, and I'll zoom in a little more, the full AOV table to see the analysis that was run, both in the grand mean column, so we can see all of the information, how things were split out, Something we might care about is the interaction, the treatment by trial interaction. So that p-value is important. And then we also have AOV tables for each individual trial column as well. And then there is an option to put graphs on this report as well. I have it turned off because it makes generating this report faster. And this is a really small criteria, only 6 columns. We're not doing a whole lot. So we only ended up with 3 pages, but most of the time you end up with a lot of pages. So just one trick that is very handy, especially in ST, is printing to Excel instead of a report that has to be paginated. Just a page doesn't lend itself good to this huge table of all of these different assessments and lots of columns. But when you print to Excel, Excel doesn't force you into a certain page size. So it actually works very well here in Excel. We get that main table. They're all in their own cells. So if you want to make your own graph or do something with the information, very accessible being in Excel, and it just keeps going to the right. So there is no weird pagination or anything like that. You just get more and more columns because there isn't anything forcing you off to separate the page out. So it works really nice, and all of the information that we have is available to us in Excel. Okay, well, that was a quick run through. Certainly we left some meat on the bone, some examples that we'll dive into more next time around. So hopefully we'll be seeing you next week as well. But worst case, make sure you register for it so you can get the recording after that if you can't join us live. So thanks everyone for your time.
Yes, thank you.
Thank you. Bye-bye.
Bye.